Hi class, my name is Valerie. I'm one of your classmates here in statistics this semester. The topic that I really want to tackle today briefly is the idea of effect sizes and Cohen's d, which is what we highlighted a lot in one of our more recent assignments. The reason why I wanted to talk about this topic was because when I took data interpretation last semester, I have to admit I was totally confused, could not understand the idea of effect sizes. I really couldn't grasp it, couldn't get my head around it. And I definitely got a better understanding of effect sizes this semester after taking statistics and doing the more recent assignment that we did. And so that's the reason why I really wanted to talk about effect sizes today and a little bit about its comparison with p-values. Because it was something that I really couldn't understand from the get-go, and I wanted to really elaborate on it today to hopefully get a better idea of it before I leave the course. So today I'm going to be talking about effect sizes and a little bit about p-values because my initial confusion really surrounded the idea that I could not understand the difference between a p-value and an effect size. So just to reiterate, a p-value or a probability value is basically telling us whether or not two variables have statistical significance, looking at whether or not a relationship exists, a trend or a pattern exists between two variables. And a light bulb moment that I had last week for this topic was I had a bit of a headache and I took an Advil. And I thought to myself, well, how much is this Advil really going to affect my symptoms of a headache? And it really kind of struck like a light bulb moment in me. And so just to kind of give you an example, if we were to maybe have two groups, a control group and an experimental group. And in the experimental group, we used the treatment of Advil to see whether or not Advil had any effect on headaches. A p-value in this experiment would really tell us whether or not Advil was statistically significant, whether or not Advil had any effect at all whatsoever on headaches. And the problem with this is it really doesn't tell us. It tells us whether or not Advil has an effect, but it doesn't tell us how much of an effect it has. And so to go back to some of the terminology that we talked about over the semester, it's not telling us, let's say, the magnitude, right? So we want to look at magnitude because that actually helps us with more practical studies in the future because we don't really care if Advil has an effect. We want to know how much of an effect it has because that really helps us with future research. So again, effect sizes really tell us how much of an effect something has or how large an effect it has. So it actually categorizes into a small, medium, or large effect. And one of the ways to measure effect sizes between two group means is what we did heavily in our last assignment, which was talking about Cohen's d. And typically we can use Cohen's d to accompany a t-test or an ANOVA test. But a Cohen's d really looks at the mean difference between our two groups here. So the mean of the group that took the Advil versus the mean of the group that didn't take the Advil. And again, we're looking at, let's say, the formula of the difference between the two means, and again, divided by the standard deviation. So with Cohen's d, we're actually looking at standard deviation differences. So like how many standard deviations are these two groups far apart in? And I guess I wish I could do a visual, but if you were to have sort of like a graph of the two means and look at sort of the how the two means kind of intercept one another or overlap each other. We're kind of counting the standard deviations between the two means. I hope that came across well. And again, so what we're getting here is basically Cohen's d, which indicates how much two groups differ by standard deviation. And we sort of have these benchmarks that we talked about in class. We have a benchmark of a small effect size, which is 0.2, a medium effect size, which is about 0.5, and a large effect size, which is about 0.8. And when you convert that to a percentage, it's kind of, the percent of, how much of the control group is below the mean of the experimental group, right? So hopefully that gives you a better visualization of, how different the two groups are. Again, a small effect size of zero point 0.2 is considered small, zero point 0.5 is medium, and zero point 0.8 is large. So essentially what we're seeing here is that the difference between these two groups, if the mean is less than zero point 0.2 standard deviations, this is a small, if not, let's say, negligible difference. So even if we have a p-value that tells us that this experiment is statistically significant, that yes, Advil does have some kind of effect. It's less than 5% chance that this is due to random chance. This is, a statistically significant a value that it doesn't tell us really how big of an effect Advil has. So if we have a 0.2 effect size, that tells us that Advil has pretty much a very small, negligible effect on headaches. If we get a d-value of 0.5, it tells us, yes, this has, a relatively medium effect size. Perhaps this is, practical for future studies. We should look at it a bit more. And a large effect size is 0.8. So that means, a greater percentage of the control group was below the mean of the experimental group, which means there's pretty much a very big effect, right? That means that, the experimental group was like really different from the control group, meaning that Advil really had some type of significant effect here. So we're really looking at the numbers, in our data set here to tell us, how different the magnitude is between the two groups. So just to kind of summarize here, I think the takeaway that really helped me out here was, again, looking at p-values, right? Because I was really confused of the difference. So p-value just tells us, yeah, hey, we've got something going on here, right? We've got some type of significance between these two groups. It tells us something. There's a relationship, and an effect size is actually really important to always report because it's actually looking at the true numbers in our data set and saying, okay, yeah, it might be different, but how different is it that we it's important for us to really have some kind of practical significance of this study, right? So that's my takeaway of effect sizes. I hope I summarized it well. I had a great time in this class. I wish I could talk about it even more, but I wanted to keep my video under the 10-minute mark. So thank you, and have a great day.